Hello viewers, this is Wagada taking you through the story of A-level applied mathematics. And in this video I'm going to go through the topic of area approximation by trapezium rule. So this video is suitable for students in both senior 5 and senior 6 offering principal mathematics as part of their combination. So briefly on the course outline so far, this is our progress. Remember, math part 2 contains of 3 parts. One is mechanics. Now mechanics is divided into 3 parts. One is kinematics, and there are 2 questions, one from section A, one from section B. The ones which are ticked are the ones we have so far covered, meaning that we are under kinematics. This topic of relative velocity has not yet been covered. Then the second part of mechanics is dynamics, and it has 2 questions still, one in section A, one in section B, and the ones which are ticked are the ones which have been covered. These ones are still pending. For statics, the last part is statics, and it also has 2 questions, one in section A, one in section B, and the ones which are ticked are the ones which have been covered. This one is still pending. Then for statistics and probability, there are 3 questions, and almost all of them have been covered except this part of permutation and combination. I think you realize that the part of elementary statistics, they are half ticked, meaning that they were one of the very first videos we did, and by that time the quality was not so okay, so we are planning to redo them. That's why they are half ticked. Then now we are on numerical methods, and numerical methods, there are 2 questions in section A and 2 questions in section B. So far we have already covered errors, and now we are covering trapezium rule. So we are aiming at first finishing all these ones before we go back to fill in the gaps for mechanics and statistics. So with that brief introduction of our progress, we shall now go to the topic of today, and that is area approximation by trapezium rule. So this is an approximate method for estimating an integral or area. This is area under a curve over an interval, say from A to B, from x equal to A to x equal to B. So we already know that given a function, the area under a curve, so this is a function representing a curve, the area under the curve from x equal to A to x equal to B is given by the integral from the lower limit, which is x equal to A, to the upper limit, which is x equal to B, of that given function with respect to the variable x. So this is a function in terms of x, that is why we integrate with respect to x. Now this is the knowledge we know under calculus or under pure mathematics. So in this topic we are going to look at a method which is known as trapezium rule, which can also be used to approximate this area. So using calculus you get the exact value of the area, or we call it the actual area, but when we use trapezium rule, what we get, we call it the approximate area under the curve. So this area is got by dividing that range, that interval, into small areas, or dividing the entire area into small areas called strips, and these strips will be in the form of trapezium. That is why we call it trapezium rule. So let's see how this is done. So we are going to use strips of width h as we have shown here. So let's first draw the curve. Let the curve be of that shape, which is y equal to fx. Then they told us that the area we want starts from x equal to A up to x equal to B. So this is x equal to A and this is x equal to B, so the whole of this is the required area. So how do we estimate that area using trapezium rule? So what we do, we divide the entire area into strips. So this is what we call a strip. From here up to here is one strip, from here up to here is the second strip, from here up to here is the third strip, like that. So in this case it means that you have divided the area into 1, 2, 3, 4, 5 strips, but there can be more depending on the question. So now we also have what we call ordinates. Now these lines are what we call ordinates. These lines which divide the area are called ordinates. Now you have seen two terms. There's what we call strips. Strips is this entire shape, which you have already said that it approximates a trapezium. The whole of this shape is a strip. But when you talk about ordinates, we talk about these lines. So x1, x0, x1, x2, x3, x4, x5 are called ordinates. Then these shapes have area. So this is area A1 is the area for this shape from x0 to x1. Then from x1 to x2 the area is A2. From x2 to x3 the area is A3. From x3 to x4 the area is A4. And lastly from x4 to x5 the area is A5. So we say that the strips are each of width h. So this width is the same from here to here, the same as from here to here, and the same as from here to here, from here to here, as you can see here. And the strip width is h. So h is what we call the strip width. So we have to know these terms because they'll be used frequently in the questions. One is the strip width, then the sub-interval, and also ordinates and what they mean. Now each ordinate has a corresponding y coordinate, also y value. So this line meets this curve at this point, and the y coordinate is this y0. For this line the y coordinate is y1. For this line the y coordinate is y2, like that. So this is for y3, y4, y5. So these values are also of greater use, and they are got from this using this function. For example, when I substitute x0 here, I'll come up with y0. When I substitute x1 here, I'll come up with y1. When I substitute x2 here, I'll come up with y2. When I substitute x3 here, I'll come up with y3. x4 here, I'll come up with y4, and x5 here, I'll come up with y5. So we shall see how all these values can be got to given the question. Here we are doing the introduction. Now, like I said, these two terms are very vital, sub-interval and ordinates. So we shall come and say that if n is the number of strips and small n is the number of ordinates, it implies that capital N is equal to n minus 1. In other words, the number of ordinates are more than this number of strips by 1. But our interest is the number of strips. That is why if you are given the ordinates as small n, you have to remember that to get the number of strips you are supposed to say n minus 1. Now how does that come about? Let's look at this diagram. If you look at this diagram, we said ordinates are these lines. So this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. Those are ordinates. But when we talk about strips, we talk about from here to here, that is one strip 1, from here to here, that is another strip 2, from here to here, that is another strip 3, from here to here, that is another strip 4, and from here to here, that's another strip 5. So we have 5 strips and 6 ordinates. I think you see that to get this number of strips, you have to get this minus 1. So in the question, they can give you either strips, they can say these strips is the same as sub-interval, so they can give you sub-intervals or strips, or they can give you ordinates. But remember that our interest is strips or sub-intervals. So when they give you ordinates, you have to remember this formula. Then after getting the number of strips, we have to get the strip, we have to also get the strip width. Strip width is given by the formula upper limit minus lower limit over number of strips. So usually they will give you upper limit and lower limit from an integral, and for you to proceed you have to get the strip width. Now how does that formula come about? We know that from here to here b minus a is from here up to here, but our interest is to get to the width for only one strip. So what we shall do, we shall get the whole of this length from here up to here and divide by the number of strips, which is 1, 2, 3, 4, 5. That is why you, from this upper limit minus lower limit, gives this whole of this interval from here up to here. The number of strips are these ones, so when you divide the two, you'll be able to get the strip width. Now these formulas are very, very vital. So if you are given strips, you just divide by the number of strips, but if you are given ordinates, you have to remember that you have to say that ordinate, number of ordinates which are given, minus 1. So this formula is also very vital. We shall see how vital it is when we start performing some of the worked examples. So considering each strip to approximate a trapezium, just as we have already said, the area of each strip can be obtained from the formula of the area of a trapezium. So we all know the formula for area of a trapezium is a half h in brackets a plus b. So for example, if I start with area A1, I think we realize that it approximates to a trapezium. For example, if you look at this shape here, so all these ones, the shape approximate to a trapezium. This one, this one, this one, this one, this one approximate to a trapezium, where the width is h, and this a and b from here to here is y0, from here to here is y1, from here to here is y2, from here to here is y3, from here to here is y4, and from here to here is y5. So when we know those sides, we can be able to get the areas. So let's see how those areas can be got. Now what we are trying to do, we are trying to derive the formula that will be used frequently in the questions given. So let's start with area A1. Area A1, the area will be given by that formula. Then when you go to area A2, the area A2 is of that shape, and this formula is that. Then area A3 will be of this shape, and that will be the formula. Area A4 will be of that shape, and that will be the formula. And lastly, area A5 will be of that shape, and that will be the formula. So after getting all those areas, we have to remember that to get the total area, you have to add up all these areas, because when you look at this diagram, you realize that the area, what you have done, you have split the area from your tier into smaller strips, A1, A2, A3, A4, A5. So to get the total area which they want, we have to add up all these areas of the strips. So now we shall come and state our total area. So total area is equal to A1 plus A2 plus A3 plus A4 plus A5. And I think we realize that we are using the approximate sign because this area we are getting is an approximate value of the area. Remember, the actual value of the area is got using calculus. So we are going to substitute. I think we realize that for each area, a half h is common. So what we do, we factor it outside, then we put the remaining part inside the box bracket. So for A1, this is what is remaining. For A2, this is what is remaining. For A3, this is what is remaining. For A4, this is what is remaining. And for A5, this is what is remaining. Then after that, you realize that y0 appears once and y5, but the rest appear twice. For example, this is y1, y1. That is why there is 2y1. This y2, y2. That's why there is 2y2. y3, y3. That's why there is 2y3. y4, y4. That's why there is 2y4. So we are going to collect the ones which appear once alone and the ones which appear twice alone. So we shall come up with that formula. Therefore, in general, the formula can be stated as follows: that the approximate value of this integral or this area is given by a half h in brackets the sum of the extreme values. These are the extreme ordinates, y0 and y5. yn. Yn is the very last, as you can see it here, first ordinate, last ordinate. Then plus 2 multiplied by the sum of the intermediate ordinates, as you can see it here, y1, y2, y3 and y4, which were the intermediate ordinates. So intermediate means that those ones which were in between. So with this is the formula which will be very much used in this question. But you have to also have knowledge on calculus, because sometimes they can ask for percentage error, relative error and absolute error. So when they ask for that, we should remember that the value of the total area A obtained in this case is an approximate value, just as I've already told you, and that means that it bears some errors. Therefore, the accuracy of this method can be increased by increasing the number of strips or ordinates within the same interval. Now, sometimes they can give you a question and they ask that how can they can first say you to capture the error, and after that they ask you how the error may be reduced or minimized. So in that case, you have to remember that the accuracy can be increased or the error can be minimized by what? By increasing the number of strips or ordinates. So this one depends on the question. If the question talks about ordinates, use the word ordinates, and if the question talks about strips, use strips, and also if the question talks about the sub-interval, use sub-interval. But the concept is that the number has to be increased and within the same interval. So the absolute, relative and percentage errors in calculating the area under the curve using trapezium rule can be given by the following expressions. So I believe this formula for absolute error, you know it, actual area minus approximate, exact value minus approximate value. But like I told you, I think you remember under the video for errors, I told you that relative error under errors is absolute over approximate. But when it comes to trapezium rule, the formula changes and we use absolute relative error B is equal to absolute error over actual area. So always remember that. Then this is percentage error. There was a P here, so this is percentage error and is equal to relative error multiplied by 100. So what we should note is that this actual value of the area is got by using calculus techniques or methods. So we must have some knowledge of integration of paper 1. So now with that brief introduction, we can now go to a number of questions so that you can easily grasp the concept or the topic. Now we shall start with question 1, which came from UNEB 2020 of paper 2 question 11, and says part A, use trapezium rule with 6 ordinates to estimate this integral correct to 3 significant figures. Then part B, evaluate this integral correct to 3 significant figures. Then part C, Roman 1, determine the percentage error in the estimation in A above correct to 2 decimal places. Then Roman 2, suggest how the percentage error may be reduced. So in this topic we are sensitive on accuracy. For example, now in trapezium rule part A, they have told us they want the accuracy correct to 3 significant figures. When they say 3, it implies that for when you're calculating, you use more than 3, and it's advisable you add 2 more. Therefore, if they say 3 significant figures, as you're calculating, you use 5 significant figures. Then at the very end, that is when you round off to the required accuracy. So always remember that. Now let's start with part A. So part A, we shall know that, remember we said the values of y are got from the given function. So we are given this integral. If you look at this, the function which was given was 1 over 2x plus 1. Therefore, that means that the values of y will be got from that very function, which is 1 over 2xn plus 1. Now I'm saying xn because they are changing. There is x0, x1, x2, x3, x4 like that, and also there is y0, y1, y2, y3 like that. So that's why I'm putting on that small n. But before anything, you have to get the strip width, that is the value of h. Now in this case, they gave us the number of ordinates, and like I told you, we're interested in the number of strips. Therefore, when they give you ordinates, you have to remember that the number of strips is equal to number of ordinates minus 1. So that is why we are using here the formula that upper limit minus lower limit over number of ordinates minus 1. So always remember that when they give you ordinates, here you have to subtract off 1 to get the number of strips. But if they give you the number of strips, just put there that very number and don't subtract 1. Hope that is clear. Now still, what we have to remember is that this value here, you only use decimals if and only if it is an exact decimal. For example, if these values are recurring or there are many decimal places, it is advisable to leave your answer in fraction form. But you realize that for this case now, when you use a calculator, you'll get exactly 0.08. So hope that is clear. If the number of decimal places are very many, don't round off at this point. Only expressed in fraction form. So you only use decimals only if it is an exact decimal. Now after getting the strip width, we shall use it to get the values of x. So let's first write the ordinates. The number of ordinates are, remember they said there are 6, so there will be 1, 2, 3, 4, 5, 6. Those are the number of ordinates. There are 6. The next is to get the values of x. Values of x, we start with the lower limit, which is 0.1. Then to get the rest, we keep on adding the strip width. So this 0.1 plus this gives you 0.18. Then this 0.18 plus this gives you 0.26, and this 0.26 plus 0.8 gives you 0.34, and this 0.34 plus 0.808 gives you 0.42. 0.42 plus 0.08 gives you 0.5, which is the upper limit. So always we start from the lower limit and end with the upper limit. That is how they generate the values of h. But when it comes to the values of y, we are going to split the two, because remember in the formula the extreme ordinates were grouped together and the other intermediate ordinates were also grouped on their own separately. Therefore, even here, when we are tabulating, we shall tabulate the extreme ordinates alone and the intermediate ordinates alone. So we are putting here y0 and y5 because this is the very first ordinate and this is the very last ordinate. So the first ordinate will be y0 and the last ordinate will be y5. That is why in this first column we are putting the extreme. Then after that, the intermediate ones, these ones, will be put in their own column. So let's first deal with the extreme ordinates. So this one is got by substituting x here to come up with this value of y. Then when I substitute this x here, I'll come up with 0.5. Then this total means that I have to add this with this to come up with that. Now the intermediate ones will have their own column, so we shall start with y1, put this x value here to come up with that value of y, put this x value here, come up with that value of y, put this x value here, come up with that value of y, and put this x value here, come up with that value of y. Then next we have to add all these ones to come up with that. I think realize that we are using 5 significant figures because the accuracy is 3, so we add 2 more to be on the safer side. Now before I go to the next slide, let's see marks for this slide. So far we have B1, a B1 for getting the strip width, B1 for generating X values, B1 for generating extreme Y values with the sum, another B1 for generating intermediate Y values with their sum. So we are going to use those values to come up with our approximate area. So we have to, I think, remember this formula. This is the formula for trapezium rule which we derived, but if you forget it, just remember that it is available in the mathematical logbooks. Now the y0 plus y5 is this sum 1.33333, and this sum from y1, all these intermediate values, their sum is given here, and that is 2.5319. I think now you realize why we had to split these two values. So you shall come and substitute those values in this formula. So when you substitute, you shall come up with that. So this was the h value, this was the sum of the intermediate, sorry, sum of the extreme, sum of the intermediate. Then when you use the calculator, you shall come up with that, but remember they gave us an accuracy, so you shall round off to the required accuracy. So that was part A. Now let's see what part B said. So part B, they want you to evaluate. Now evaluating means they want you to get the actual area, and actual area is got using calculus. So we shall integrate that. When I integrate this, I'll come up with a half ln 2x plus 1. So you already covered integration still on this very platform, so you can go to the playlist and find out more about integration. So then put on the limits 0.1 to 0.5. So we are going to substitute the limits. Begin with the upper limit, put where there is x, put there 0 upper limit to come up with this, and also where there is x, put on the lower limit to come up with that. In the end, you shall come up with a half ln 2, which is equal to 0.255. I think we realize that the accuracy which is given in part A is the same accuracy we use in part B. So usually in part B they will not specify the accuracy, but for you to know the accuracy to use, recall the one used in part A. Always remember that. So M1 for the substitution, A1 for the output to the required accuracy, M1 for integration, M1 for substituting limits, A1 for the output to the required accuracy. So that is part B. Now we shall go to part C. Part C, Roman 1, they want you to get the percentage error correct to 2 decimal places. Then Roman 2, they want you to suggest how the percentage error may be reduced. So we have got the approximate value. This is the approximate value, and this is the actual, or the approximate area, and this is the actual area. So we shall use those ones to get the absolute error. Remember, absolute error is given by the formula actual area minus approximate area. But remember, because it is absolute, we have to put those symbols. Now these symbols to show magnitude are very, very vital, because sometimes after subtraction you'll get a negative value. Now these magnitudes help you to eliminate that negative value. So this is the formula for percentage error, relative error multiplied by 100. So when I substitute, actual area was this, approximate was this, over actual area multiplied by 100. Then when I use a calculator, I'll come up with this. I think we realize that if I say this minus this, I'll get a negative, but at the end I don't put that negative there because of this magnitude signs. Then remember to set the answer to the required accuracy. Roman 2, they want you to suggest how the percentage error may be reduced, and like we saw in the introduction part, it is reduced by increasing the number of ordinates. Now, I think realize that now we are using this word ordinates. Why? Because the question was talking about ordinates. If the question was talking about strips, we'll just remove this word ordinates and put there the word strips. If the question was talking about subintervals, we'll just remove this word ordinates and put there the word subintervals, but the rest remains the same. So M1 for the substitution, A1 for the output, M1 for B1 for that suggestion. So this question 1, we have taken a lot of time to explain every detail because I wanted you to understand how the question can be approached. So the preceding questions we shall be a little faster. So now we shall go to question 2, which came from UNEB 2019 paper 2 question 3, and says use trapezium rule with 7 ordinates to estimate this integral correct to 2 decimal places. So the first thing to do is to remember that real value of y is this function which is given, and the strip width is given from got by getting the difference of these limits, upper limit minus lower limit over number of ordinates minus 1. Remember I said when they give you ordinates you have to remember to subtract off 1. So this is also an exact decimal, which is 0.5. So now that you have got the strip width, we can tabulate our value. So we shall begin with our number of ordinates. Now the number of ordinates were 7. That is why you see here 1, 2, 3, 4, 5, 6, 7. Now it is not a must that you should begin from 0. As long as you are consistent, you can begin from 1, 2, 3, 4, 5. So that means that the end value will be 7. If I begin from 0, it stops at 6. And if I begin from 1, I will stop at 7. So any is okay. Next is the values of x. So values of x, I'll keep on adding this. I'll start with the lower limit, which is 0, then keep on adding 0.5 to come up with this, 0.5 to come up with this, 0.5 to come up with that, 0.5 to come up with that, 0.5 to come up with that, 0.5 to come up with that. Next is to get the y values. I'll begin with the extreme. Extreme is this and this. That is why you see here y0 and y6. So when I substitute this value of x here, I'll come up with that. When I substitute this value of x here, I'll come up with that. When I add the 2, I'll come up with that. The next is to get the intermediate values. So get this value of x, put it here, come up with that. Get this value of x, put it here, come up with that. Get this, put it here, come up with that. Get this, put it here, come up with that. Get this, put it here, come up with that. The next add all these values to come up with that. So I think realize that the accuracy was 2 decimal places, therefore I have to add on 2 more. That is why I'm using 4 decimal places throughout. So the accuracy is very vital in this topic. Therefore, we shall now substitute. It's not a must that you should quote the formula, as long as you know that it will be a half times h times in brackets this sum of the extreme values plus 2 times the sum of the intermediate values. So as long as you know that formula, there's no need to quote the formula first because it is already there in your mathematical table. So next, when you use the calculator, we shall come up with this. Then you remember our accuracy. That is, after that we shall round off. So this writing this one is not a wastage of time. This value is required because we have to see how you round it off. So B1 for getting the value of h, B1 for generating x values, B1 for generating y values, both of them. B1, M1 for this substitution, A1 for the output to the required accuracy. So now we shall go to question 3, which came from UNEB 2018, paper 2, question 11. It says, using trapezium rule with 6 ordinates, estimate the value of this correct to 3 decimal places. So let's start with that one. So the first thing to do is to get the value, the expression for y. So this is the function which was given in the integral, and that becomes our y. Then next is to calculate the value of h. Value of h is upper limit minus lower limit over number of ordinates minus 1 to come up with this. I think we realize that now we are using pi. So this pi you don't substitute. Some students may say, let me substitute and it becomes 22/7 or 3.14, but you don't substitute because the calculators we use are scientific calculators and they have this symbol pi. So next is to first tabulate our ordinates. Then after tabulating ordinates, we shall go to our values of x. So values of x start with the lower limit, which is 0. Then add on this to come up with that. Then add on this to come up with that. Add on this to come up with that. Add on this to come up with that. And add on this to come up with that. So next is to generate values of the extreme values. So this is the extreme and this is the extreme. That's why here there is y0 and y5. Now, as long as you see this trigonometrical function, what should come in your mind is that the calculator has to be in radians. So after setting your calculator in radians, what you're going to do, you'll come and put where there is x, put there this value to come up with, you'll realize that you get that value. Then after that, get this value and put it here, you realize that you come up with that value. Then also I think you realize that we are using 5 decimal places because the accuracy is 3 decimal places. So we add on 2 more. Then you have to get the total, which is that. Then the last column will be for the intermediate values. So still the calculator should be in radians. So substitute this one here and here where there is x to come up with that. Then substitute this one here and here to come up with that. Substitute this one here and here to come up with that. Substitute this one here and here to come up with that. Then next use the calculator to add these ones to come up with that. So that is our tabulated values. B1 for the value of h, B1 for generating values of x, B1 for generating extreme values of y, B1 for generating intermediate values of y. But remember, they want the approximate area, so we shall come here and substitute our values. Like I said, there's no need to code the formula. Substitute and then come up with our answer. First of all, you write this one with more than 3 decimal places, then after that you round off to the required accuracy. Like I said, writing this one is not a wastage of time, it has to be seen. Now that was part A. Let's go and see part B. So part B, Roman 1, they said evaluate this. When you see this word evaluate, it means that they want you to use knowledge of calculus to come up with the actual value of this integral, correct to 3 decimal places. Then Roman 2, they want you to calculate the error in the estimation. So when they just say error, it means they want absolute error. Then Roman 3 suggests how the error may be reduced. So we have to integrate that one. So when I integrate x, I'll come up with a half x squared. Integrate sine, I'll come up with negative cos x. Limits are these ones, lower limit, upper limit. Then when I substitute the limits, I'll come up with that. Use the calculator should be in radians, so you come up with this value to 3 decimal places. Then Roman 2, they wanted the absolute error, so error is actual minus approximate. So actual is this approximate is that. So come up with 0.009. Then lastly, they wanted you to state how the error may be reduced. So it may be reduced by increasing the number of ordinates. So the question talked about ordinates, that's why you are using the word ordinates there. So M1 for substitution, A1 for the output to the required accuracy, M1 for integration, M1 for substituting limits, A1 for the accuracy, output the required accuracy, M1 for this, the magnitude sign has to be seen, then A1 for the output, then B1 for suggestion, correct suggestion. So that was question 3. Now we shall go to question 4, which came from UNEB 2006 paper 2 question 3, and says using the trapezium rule with 4 sub intervals, estimate this integral correct to 3 decimal places. So like I've already said, we are first getting the value of y, which is the given function, then get the value of h, upper limit minus lower limit divided by, now here they given a sub interval, so you don't subtract off 1. I think you remember that when they give you sub intervals or strips, you don't subtract off 1, but when they give you ordinates, you have to subtract off 1. So we shall come up with pi over 8, and like I've already said, don't substitute for pi, just leave it as pi because the calculator has that symbol of pi. The next is to generate the value, first out the column for ordinates. After generating that, we should generate the column for x values. So if you start with the lower limit, then keep on adding this to come up with this, add this to come up with that, add this to come up with this, add this to come up with that. The next is to generate the values of the the extreme, this and that. That's why you see a y0 and y4. So when I substitute this, the calculator has to be in radians because of this. So when I substitute this 0 here, I'll come up with that. When I substitute this one here, I'll come up with that. So when I add the 2, I'll come up with that. The next is to generate the intermediate. So substitute this one here to come up with that, substitute this one here to come up with that, substitute this one here to come up with that. I think you realize that we are using 5 decimal places because the accuracy wanted 3. So next is to add all these values to come up with that. So B1 for h value of h, B1 for the values of x, B1 for both columns of y. So next we shall use what we have got to substitute in the formula for trapezium rule. Then we use a calculator to come up with that and round off the required accuracy. Like I said, writing this value is not a wastage of time, it has to be seen. So M1 for the substitution, A1 for the output to the required accuracy. So that was question 4. Now we shall go to question 5, which came from UNEB 2012 paper 2 question 3, and it says use trapezium rule with 4 sub intervals to estimate this integral and give your answer correct to 3 decimal places. So the first thing to do is to get the value of y, which is the given function they want you to integrate, and then we get the value of h, which is upper limit minus lower limit over number of sub intervals to give you pi over 8. Then we shall substitute, we shall tabulate our values, start with by listing the ordinates. Then next we shall generate the values of x. So we start with the lower limit, then keep on adding this. When I add that, you can come up with that. Add that, come up with that. Add this, you come up with that. Add this, you come up with that. So next is to come up, generate the column for extreme values of y. So this and that. So substitute this one here to come up with that, and substitute this one here to come up with that. Then when I add the 2, I'll come up with that. Then now I'll go to the intermediate values. So get this value, put it here, come up with that. Put this one here, come up with that. Put this one here, come up with that. then add all these three to come up with that. So B1 for generating getting the value of h, B1 for generating values of x, B1 for generating both columns of y. So next we substitute in the formula for trapezium rule and come up with the accuracy which is required. Like I said, this value is needed. So let's see how much can be awarded. So M1 for the substitution, A1 for the output, the required accuracy. So that was question 5. Now we shall go to question 6, which came from UNEB 2011, paper 2, question 11, and says, part A, use trapezium rule with 5 sub-intervals to estimate this integral correct to 3 decimal places. I think let's start with that. So the given function is tan x, so that will be the value of y. Then we shall get the value of h, upper limit minus lower limit over number of sub-intervals to give you pi over 15. Then we shall tabulate our value. Start by listing the number of ordinates. Then after that we shall go and generate the column of x. So x will start with the lower limit, which is 0. Then keep on adding this to come up with this. Add this to come up with that. Add this to get that. Add this to get that. Add this to get that. So yeah, that this is the very value as the upper limit. So next we generate the values of y for the extreme values. So this and this. That is why there is y0 here and y5 there. So get this, because of this tan, calculator should be in radians. So get this, when the calculator is in radians, get this value of x, put it here to come up with that. Get this value, put it here to come up with that. Then add these two values to come up with that. The next is to get the values for the intermediate. Get this value, put it here, come up with that. Put this one here, come up with that. Put this one here, come up with that. Put this one here, come up with that. Then add all these values to come up with that. So basically that is the tables. So B1 will be for getting the value of h, B1 for generating values of x, B1 for generating extreme values, B1 for generating intermediate values. So now shall use those values to get the approximate area. So shall come and say that approximate area or approximate integral is that. So this symbol is very vital. We use the calculator to come up with this, and that will be the approximate value. So now we shall go to part B. Roman 1 says find the value of this integral correct to 3 decimal places. So they want you to use calculus. Then part B, calculate the percentage error in your estimation in A above. Then part C suggests how the percentage error may be reduced. So actual value of this is equal to this. So when I integrate tan x, I come up with negative ln cos x. Then put the limits, which are 0 to pi over 3. The next is substitute the limits, which will be that. And then I'll come up with these 2 3 decimal places. So this accuracy is the same accuracy here. Then Roman 2, they wanted the percentage error. Percentage error is equal to absolute over actual multiplied by 100. So absolute error is actual minus approximate over actual multiplied by 100 to come up with 1.587. Then Roman 3, they wanted you to suggest how the percentage error might be reduced. So that will be by increasing the number of sub-intervals. I think you realize that when the question talks about sub-intervals, you use sub-intervals. So M1 for this substitution, A1 for the output, the required accuracy, M1 for this integration, M1 for this substitution, A1 for this output to the required accuracy, M1 for the substitution, A1 for the output, B1 for the correct suggestion. So that was question 6. Now we shall go to question 7, which came from UNEB 2009 paper 2 question 6, and says, using trapezium rule with 6 ordinates, estimate this integral and give you answer to 3 decimal places. So the first thing to do is to remember the value of y is a given function. Therefore the value of h is upper limit minus lower limit over number of ordinates minus 1 to come up with 0.2. This 0.2 is an exact decimal, otherwise I would have written a fraction. So next is to tabulate. We shall start with the ordinates, then we shall go to the values of x. So values of x, we start with the lower limit, which is 1, then keep on adding this to come up with this, add this to come up with that, add this to come up with that, add this to come up with that, add this to come up with that. The next is the extreme values. So here there's no need to put the calculator in radians because there's no trig function. So where there is x, put there this to come up with that. Where there is x, put there this to come up with that. Then add these two to come up with that. The next is to generate values for the intermediate values of y. So get this, put it here and here to come up with that. Get this, put it here and here to come up with that. Get this, put it here and here to come up with that. Get this, put it here and here to come up with that. Then next add all these values to come up with that. All that we shall now substitute in our trapezium formula to come up with our answer as 0.237. Correct to 3 decimal places. So B1 for the value of h, B1 for the values of x, B1 for both columns of y, M1 for the substitution, A1 for the output. So that was question 7. Now we shall go to question 8, which came from UNEB 2008 paper 2 question 5, and says, use trapezium rule with 6 ordinates to evaluate this. Correct to 2 decimal places. So the first thing to do is to get the value of y, which is a function they want you to integrate. Then the value of h is upper limit minus lower limit over number of ordinates minus 1 to come up with 0.2. Next is to tabulate. We start by listing the ordinates. Then after that we list the values of x. So we start with the lower limit, then keep on adding this to come up with that, add this to come up with that, add this to come up with this, add this to come up with that, add this to come up with that. Next is to generate the values of the extreme. So where there is x, get this value of x, put it here to come up with that, get this value, put it here to come up with that, then add these two to come up with this. So I think you realize that you're using 4 decimal places because the accuracy is 2 decimal places. The next is the intermediate values of y. So intermediate values of y, when I put this value of x here, come up with that, put this one here, come up with that, put this one here, come up with that, put this one here, come up with that. Then next add all these values to come up with that. So after that we shall now substitute in our formula for trapezium rule, then use a calculator to come up with our answer as 0.74 to 2 decimal places. So B1 for getting the value of h, B1 for getting values of x, B1 for both columns of y, M1 for the substitution, A1 for the output to the required accuracy. So that was question 8. Now we shall go to question 9, which came from UNEB 2007 paper 2 question 3, and says, use trapezium rule with 7 ordinates to find the value of this integral. Correct to 2 decimal places. So the first thing to do is to get the value of y, which is the given function to integrate, then get the value of h, upper limit minus lower limit over number of ordinates minus 1 to come up with pi over 6. The next is to tabulate. We start by listing the number of ordinates. The next is to generate the values of x. So start with the lower limit, then keep on adding this to come up with this, add this to come up with that, 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 add this to come up with that. So next is to get the values for the extreme. Now because of this trig, the calculator should be in radians, so after putting the calculator in radian mode, you get this value of x, put it here and come up with that. Get this value, sorry, this extreme, put it here and come up with that. Then add these two to come up with that. Then we shall go to the intermediate ones. Put this one here, come up with that, 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 put this one here, come up with that. Then add all these values to come up with that. So I think you realize that I'm using 4 decimal places because the accuracy is 2, so I add 2 more. So B1 for getting the value of h, B1 for the values of x, B1 for both columns of y. So now we can substitute in trapezium rule to come up with that. Then when you use the calculator, come up with that, round off the required accuracy to come up with that. So M1 for substitution, A1 for the output to the required accuracy. Then that was question 9. Now we shall go to question 10, which came from UNEB 2005, paper 2, question 10, and says Roman 1, use trapezium rule to estimate the area of y equal to 3x between the x-axis, x equal to 1 and x equal to 2 using 5 sub-intervals. Give your answer correct to 4 significant figures. So let's start with that. So first is this is the value of y, then the value of h will be upper limit minus lower limit over number of sub-intervals to give you 0.2. Then after that we shall now tabulate our values. Start with the number of ordinates and list them down. Then we shall go to the value of x. So start with the lower limit, which is that. Keep on adding this to come up with that, add 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 this to come up with that. The next is for the extreme values. So get this value, put it here to come up with that. Get this value, put it here to come up with that. Then add these two to come up with that. The next is the intermediate. Get this value, put it here, come up with that. Get this value, put it here, come up with that. Get this value, put it here, come up with that. Get this value, put it here, come up with that. Then add all these values to come up with that. So next is to use trapezium rule to substitute and then use a calculator to come up with the required accuracy of 4 significant figures. So when they say 4 significant figures, we use 6. So 1, 2, 3, 4, 5, 6. That is why we are using 6 significant figures. So B1 for the value of h, B1 for the values of x, B1 for the extreme values of y, B1 for the intermediate values of y, M1 for substitution, A1 for the output to the required accuracy. So now we shall go to Roman 2, where they want you to find the exact value of this integral, and part C, or Roman 3, determine the percentage error in calculating Roman 1 and Roman 2. Now this integral, the form, okay, let's go to the solution. So what I was saying, that integrating 3 to power x or a constant to power a variable, the formula is there in your mathematical logbooks, but let us try to derive it, though it may cost no mark. So there's no mark will be given for you to be able to derive this integral, but let's do it for you to understand it. But to understand it further, you go to integration under paper 1, and that video is also there in this platform of ROA. So what we do for you to get this integral, first we are going to differentiate, because we know that integration is the reverse of differentiation. So the easiest way is to differentiate, but for you to differentiate this variable power, you have to first introduce natural log. So introduce ln on both sides to come up with that. Then differentiate. When I differentiate ln y, I'll come up with 1 over y dy dx. Then when I differentiate this one, I realize that ln 3 is a constant. So when I differentiate x, I get 1. That's why I remain with ln 3. Then when I cross multiply, I realize that dy dx is equal to ln 3 multiplied by 3 to power x. Why? Because this y has come this side, but I know that y is equal to 3 to power x. That is why there is this 3 to power x. So from there, I'll know that when I differentiate 3 to power x, I'll come up with ln 3 multiplied by 3 to power x. Because I get that, it implies that when I integrate this, I'll come up with this, because it implies that when I integrate this one, this will go this side to come up with 3 to power x over ln 3. So this is the formula I was telling you, that this formula is standard and it's there in your mathematical logbooks if you know how to use them very well. But if you don't know, you have to go through all these steps. However, going through all these steps, there is no mark given. So the marks will be from here. So integrating this gives me that, then substitute the limits and get the output to the required accuracy. Then Roman 3, they wanted percentage error. Remember, percentage error is absolute error over actual value. So the calculator will give me that as the answer. So basically that is what they wanted. M1 for this integration, M1 for substituting limits, M1 for the output, the required accuracy, M1 for getting absolute error, and M1 for the division, A1 for the output. So like I've already said, we are working on a project where I want to convert our books, hard copy books, into video lessons. So this content was got from this book of Mastering A-Level Math paper 2 and this A-Level Question Bank. So in case you want them, you can contact the author on these contacts. Then also content of Math 2, Math 1 is from this book, and content of Physics 1 is from this book, content of Physics 2 is from that book. Then when it comes to O-Level, this one is for Senior 1 and Senior 2, and this one is for Senior 3 and Senior 4. When it comes to Submath, we have that book. When it comes to, we also have this O-Level Question Bank and also O-Level Question Bank of Math. So our question banks, the topics are arranged topical for both Physics O-Level A-Level and Math O-Level A-Level. So that brings us to the end of this video. Thank you for watching, and be reminded that the next video will be on linear interpolation and extrapolation. So if you're not yet subscribed, please click on the subscribe button below this video, and also if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family.